Okay, welcome back. We'll be continuing on today in Chapter 8. Today, we're looking at partial fraction decomposition. And here's the idea. If we wanted to add these fractions together, we know how we would do it. We would need a common denominator. Here, see that I have a factor of x and a factor of x squared plus 1, which is repeated twice. So the common denominator would be x times x squared plus 1 squared. I would have to multiply this negative 10 by x squared plus 1 squared in order to balance out. The second fraction, x squared plus 1 squared, means that we are missing an x and an x squared plus 1. And in the third fraction, x squared plus 1 squared, we have got two x1 plus 1 squareds. We are only missing an x. Therefore, we would just say that the entire thing is x times x squared plus 1 squared, and then we would have all of these other numerators added together. Now, of course, we could simplify the numerator and denominator, expanding them out. But the idea is this. We see that the numerator of the denominator of the final answer is exactly the same as the pieces that we had in the originals. But because one of these pieces was repeated, we ended up getting only the largest power in the final answer. Going forward is quite easy. Our goal today is to go backwards. This is going to be a technique that's immensely helpful when you get to calculus, and it's called partial fraction decomposition. Now, here's what we're going to be looking at. If I've got a fraction, a rational function where the numerator is a smaller power and the denominator has no factors in common with the numerator. In other words, if the numerator has power equal to or greater than the denominator, you should use polynomial long division to divide it out. And if there are any factors you should cancel, you should do so. Look at all of the rest of the factors. You will be able to create a new bunch of fractions that add up to the original by looking at the factors. Whatever the power is of each factor, that's how many fraction pieces we'll need to consider. If the factor is linear, just an x and maybe a constant, then the numerator will just be a constant. If, however, the denominator is a quadratic with an x squared and x and a constant, then the numerator will be linear with an x and a constant. These will only show up if that the numerator is smaller in power than the denominator. So make sure you use long division if this isn't the case to solve this issue. With all that in mind, let's just go through 3 examples so we can see what's going on here. We'll start off simple. 2x over x squared minus 1. We're going to factor the denominator into x plus 1, x minus 1. That means that the partial fraction decomposition will have the form a over x plus 1 plus b over x minus 1. We will then go ahead and factor this. Multiply to clear our denominators. So we're going to multiply both sides of this equation by the big numerator, x plus 1, x minus 1. Now on the left-hand side, of course, this just canceled and we're left with 2x. On the right-hand side, this gives us a times x minus 1 because the x plus 1 cancels, and similarly b times x plus 1 because the x minus 1 cancels. Now, there are 2 ways that we can solve from here. I like to call this the fast way and the reliable way. The fast way is going to be quicker, but it does not always work. However, for simple problems like this, it would be my go-to. The reliable way is good because it will work for every type of problem, and as a result, we of course need to know it. I'll show you both here. For the fast way, you're going to plug in numbers for x. You want to do numbers that will cancel out some of these capital letters A and B. So let's try, for example, x equals 1. This gives us 2 times 1 is equal to 0a plus 2b. In other words, b is equal to 1. Similarly, if x is equal to negative 1, then 2 times negative 1 would be negative 2a plus 0b. In other words, a is also equal to 1 here. Thus, we get as our final answer 1 over x plus 1 plus 1 over x minus 1. You plug in numbers that causes some of the variables to drop out, and you repeat this until you got all your answers. The reliable method does not involve plugging in for x at all. Instead, we will factor both sides, or FOIL and distribute on both sides. 2x would be ax minus a plus bx plus b. We will then group by variable. 2x is equal to a plus bx plus negative a plus b. Then you will line up the coefficients of the like variables as well as the constants. So we get 2 is equal to a plus b, and 0 is equal to negative a plus b. This is a system of equations which we can solve, for example, using Gauss elimination from the last section. Solving this system here would give us a equals 1 and b equals 1. In either case, this will be our final answer. Once again, I recommend trying the fast method first, but sometimes it's not possible to cancel everything out properly, and you'll have to use the reliable method. Let's do another one. This time, we've got 5x cubed minus 5x squared. Now, here, we would like to factor the denominator first. 11, all right, so let's do it over here. 11x squared minus 5x minus 10 over 5x squared times x minus 1. That means that we're going to have a over x, b over x squared, and c over x minus 1. Because a factor is repeated, we will have to ascend and do x and x squared for this factor. We will then just keep the 1/5 out front of the entire thing. We could choose to bring it inside and include the 1/5 on any given piece. We're going to choose to pull it out of the entire everything, just to make our life a little bit easier. So ignoring the 5 for the moment, since we're going to come back to it at the very end, what we are going to get is 11x squared minus 5x minus 10 is equal to ax times x minus 1 plus b x minus 1 plus c times x squared. We're going to start out by using the fast method as much as we can. If x is equal to 1, then the a and b term will cancel. We will get 11 minus 5 minus 10 is equal to c, which means that c is equal to negative 4. Next, we'll plug in x equals 0. This time, a and c will cancel, and we're left with negative 10 is equal to negative b, or b is equal to 10. Now that we've solved for 2 of the variables, we can solve for a just by plugging in any old number and what we know about b and c to get the final answer. Let's plug in negative 1 for x, because that will be the easiest to work with the x squared. So this will be 11 plus 5 minus 10 is equal to negative a times negative 2. So that will be negative 2a minus b, but b is 10, so we can put 10 in, and then plus negative 4c, so minus 4. Now we'll just have to go ahead and solve for a. So 16 minus 10 is 6, is negative 2a minus 16. Negative 2a would be equal to 22, which means a is equal to negative 11. Thus, for our final answer, we get negative 11 over x plus 10 over x squared minus 4 over x minus 1. We will need to multiply the entire thing by 1/5 to account for that 5 we pulled out at the beginning, and that will be our final answer. Let's go through one more problem. Now, this problem has a big denominator, but we were given a hint that's going to make our life easier. Rather than having to use the rational root theorem to do lots of trial and error, the denominator has a root at 2 of multiplicity 2. We'll begin by using synthetic division to divide this root away. 1 minus 4, 8 minus 16, 16. We should get out 0 here. Let's just make sure. 1, 2, negative 2, negative 4, 4, 8, negative 8, negative 16, 0. Good. We'll repeat the process one more time. We should once again get a remainder of 0. 1, 2, 0, 0, 4, 8, 0. Good. This leaves us with x squared plus 4. So that means that our fraction has denominator that factors out into x minus 2 squared times x squared plus 4. Now, x squared plus 4, we could factor further by using complex values, but we're not going to. We're going to concern ourselves only with real values, and it does not reduce any further if we're just concerning ourselves with the reals. As a result, this is what we will be looking for. A over x minus 2 plus b over x minus 2 squared plus, since our third denominator has a quadratic, we'll need cx plus d as our possibilities. Now we're going to go ahead and multiply to cancel out, and we will be left with 4x cubed minus 9x squared plus 12x plus 12 is equal to a times x minus 2 times x squared plus 4 plus b times x squared plus 4 plus cx plus d, all multiplied by x squared plus 4. Sorry, not x squared plus 4. That was the piece that should have canceled. X minus 2 squared. Now we can see here that we already know that the fast method will not be able to get us to the end because there's nothing I can do that will cancel out c but not d, or vice versa. Therefore, we're going to need to go through and do this the old-fashioned way, the reliable method. What we're going to do is we're going to need to distribute out the right-hand side. I'm going to go ahead and do this very quickly so that you can see how it comes out. Here is what we get after simplifying and reducing. There's a lot of algebra to get us here, but we get a plus c x cubed, negative 2a plus b minus 4c plus d x squared, 4a plus 4c minus 4dx, and then negative 8a plus 4b plus 4d. We can line this all up to create ourselves a system of equations. We will get a plus c is equal to 4. Negative 2a plus b minus 4c plus d is equal to negative 9. 4a plus 4c minus 4d would be equal to 12, and negative 8a plus 4b plus 4d would be equal to 12. This system of equations we will solve using Gauss elimination. Once again, I'm going to go ahead and do this off to the side so you can see the final answer. After solving, we obtain 1 for A, 4 for B, 3 for C, and 1 for D. Thus, our final answer, after filling in these pieces into the form we're looking for, will be 1 over x minus 2 plus 4 over x minus 2 squared plus 3x plus 1 over x squared plus 4. Some of these problems are quite long and messy, but the idea is fairly straightforward once you get used to it. Set up the general form, multiply to clear denominators, either use the fast or reliable method to solve for the constants, and plug back into the form. That's all we've got for today. Have a great day.